right, this is chapter 10, the senses. All right, we've talked about sensory receptors versus motor, and sensory, of course, are sensations or things in the outside world. Impulses start from the outside and they work their way on the inside. Okay, so this is something we saw really with the nervous system. Sensory receptors are in two different categories: somatic senses, which are widely distributed, which we talked about with nervous, and special senses, which is what we're going to talk about with this chapter. All right, so there are some different types of sensors that you should be aware of. All right, chemoreceptors, the word chemo, of course, refers to chemicals. Pain receptors, of course, respond to pain. Thermoreceptors, thermo, of course, is temperature. Mechanoreceptors are mechanics, so to pressure and movement, and photoreceptors are found in the eyes, and they are responsible for responding to light. A sensation is anything that occurs outside the body that the brain receives, and our perception is when it interprets this information, so when we have a lot of different info coming in at one time, that is perception. The brain uses projection then, okay, to go back to a point of origin. So when we feel something, right, so if we touch something with our hand, we actually interpret that or have perception with our brain, but we feel it, okay, in our hand, because that is the point where we actually touch something. And it really does depend on what part of the brain, okay, that those nerves went to. So the nerves in your fingers go to a very particular part of your brain, and that's why you feel it in your fingers. The stuff from your legs go to a different part of your brain, which is why you feel it in a different location. The brain prioritizes everything, so a lot of times you'll notice that the more you smell something, the more you hear something, the less pronounced it becomes. So let's say, for example, you were hearing a loud noise. Over time, it would start to be less and less. Okay, you would actually be bothered less and less by it. If you smell a bad odor, okay, at first it smells terrible, and then over time, okay, you actually stop smelling it so much. All right, our general senses are a lot of the stuff we talked about, again, with the nervous system. So these are touch, pressure. We'll talk a little bit about temperature sensors. These are mostly found in the skin, parts of the muscles, the joints, and inside your viscera, which is part of your abdominal cavity. And we looked at free nerve endings, okay, in the epithelium, which is the skin tissue, and those free nerve endings help you with itching. Tactile, what we call Meissner's corpuscles, look like little circular nerves that end at the undersurface of the skin, and they are very sensitive to light touch. Lamellated or Pacinian corpuscles, again, they look a little bit more like an onion, and these are for deep pressure. So what I really want you guys to know is that there are different types of nerves that are associated with different types of sensations. So the stuff that's associated with itching isn't the same that's associated with very soft touch, isn't the stuff that's associated with pain or with deep pressure. And this picture is really just demonstrating the fact that they are all found underneath the skin. And you can see here A, B, and C. Okay, free nerve endings just look like they sort of branch out a little bit, and you can see them here. I'm putting a little circle around it. Okay, you've got your Meissner's corpuscles right here, okay, which are at the very surface of the skin, and that is, again, light touch, and that's why they're at the surface of the skin. Your Pacinian corpuscles are a little bit deeper, which makes sense because they do deep touch. We do have temperature sensors, okay, inside our surface of our skin. They are free nerve endings. There are ones for warm sensations, so for hot, and some for cold sensations. And they really work best within a range. They both respond very, very quickly. Okay, we don't want to touch a hot stove and not be able to respond to that very quickly. Temperatures about 45 degrees Celsius, okay, start to stimulate pain, so very hot temperatures. And if it gets very cold, so below 10 degrees Celsius, okay, also produces a very freezing and a painful sensation. So it should signal to you to pull your hand away, okay, from the object that you're touching. All right, our sense of pain, or what we consider to be painful, are free nerve endings underneath the skin. And when we damage the tissue, okay, they send pain up to the body. So when you sprain your ankle, okay, those free nerve endings are damaged underneath the surface of the skin, and they send pain all the way up to your brain. They're pretty much all over the body except for in the tissue inside the actual brain itself. So your brain doesn't actually experience any pain. There's a lot of different things that can trigger these pain receptors, so things like chemicals, drugs, too little oxygen, and pain receptors are very poorly understood, which is why we have such a difficult time dealing with pain management in the healthcare field. Visceral pain, that is pain in the abdomen and around the organs. These do produce some sensations. They usually come from decreased blood flow or oxygen deprivation, certain chemicals. And for the most part, we refer to this as referred pain, meaning that when we have pain in our stomach, we don't actually feel it in our stomach, we feel it in our side. When we have pain in our gallbladder, we actually often feel it up into the chest. Okay, which is why when we have heart attacks, our common pain referral is to the left arm. I'm going to show you a diagram on the next slide of where the common pain referral pathways are. All right, so you can see here, especially for the heart, which is dark red, okay, it's not the heart that actually is painful, but you can see it shoots pain down the left arm, a little bit into the back, maybe the upper shoulder, into the jaw, depending on which diagram that you're looking at. Pain fibers come in one of two sorts, either acute or chronic, and acute, of course, is very sharp, very rapid, very fast. Those tend to be very short-term, very painful, but then stop as soon as the stimulus for the pain stops. Chronic is the stuff a lot of people experience. It moves very slowly. These are unmyelinated fibers, okay, whereas acute pain fibers have myelin around them. These ones are more dull, achy, and they really take a long time for pain sensation to stop, which is why folks who, once they start experiencing chronic pain, have a very difficult time stopping the pain sensation. Part of it is the type of nerve that's taking the pain up to the brain. All right, pain impulses are processed in the gray matter portion, okay, of the spinal cord. Don't worry about the horns. And then they go up to the thalamus, the hypothalamus, and part of the cerebral cortex for interpretation. All right, when a person becomes aware of pain, it reaches the thalamus, but the cerebral cortex actually judges how intense is that pain, where is the location of that pain, as well as if we have any emotional responses to that pain, and if we have motor responses like grimacing, wincing, limping, pulling away, okay, that would all be a motor response. Again, this all comes from the gray matter of the brain. Okay, don't worry too much about those last things, the enkephalons and the serotonins. We did talk about neurotransmitters, which is what those two things are, and they help to regulate our pain sensations. Endorphins are released in the brain. They are a neurotransmitter, and they help to reduce pain. Okay, these are natural painkillers. They work just like opiates or morphine, and endorphins are often released when we exercise, have happy feelings, happy thoughts. Okay, you receive positive pain control. Some studies even show that things like music, okay, can help to release endorphins, okay, which help to reduce our pain naturally. All right, our next lecture will be on special senses, and go on to your next video.